recursive function using the recursive abstractions. But for a lazy functional language like Haskell, we can actually support recursion without using this construct, because it's just blowing up the core language syntax. So we can simulate you by using the following meta function, and this meta function fix is actually you can think about is a prelude library functions can be looked up anywhere, anytime. Okay, for example, where this fix somehow in the prelude or meta environment was defined as following, where fix is defined as a function that expecting a argument f and returning by applying this argument f as a function to fix of f itself. So notice that the definition of fix is already recursive, so we can't use the fix reason about fix itself. So this has to be on some kind of meta level. So now we call our last example of the length function, we can rewrite into for the following. So instead of using the mu x, or instead of using the mu g something, we can just call fix applied to the g is still here, because now g becomes a placeholder for the recursive core. So we still need to introduce a lambda g here, okay, as I've exposed the just one lambda x. So this g, you think about, is actually the handler for the recursion, okay, and this will be needed for apply to fix. Okay, so g is used here. Okay, we replace the recursive definition of length by g here. So now this entire expression can be evaluated using the operational semantics without the unrolling rule. And return derivation of the last example using the fixed combinator to implement the recursions. So we write our running program in the following. We say let length equals a fix applied to the lambda g, right arrow lambda x, case x of, and this pattern matching. And then we have the let y equals to this list, which is 1 plus 1 const 2 plus 2 const empty list, and in length y. And similar to the other example, you can just apply 2 steps of the let rule to replace or to substitute the length by this fixed applications, and then the y by the list. So we arrive at a intermediate expression in this form, which is a application. So notice that this function applications is not yet in a regex form, because like the first sub-expression is not yet in a lambda abstractions. What we see is actually another application. So we look into that. So we apply app2 here to reduce this. Okay, whatever seen in this rectangle box will be the subderivation of this expression. So because of this expression is applications, we first look at whether or not the sub-expression on the left hand side is it a lambda expression, but actually it's not yet, so it's a fix. So since fix is treated as a meta variable that recorded in the meta environment or prelude, we can just look it up in the environment to figure out that, wow, it is actually a definition is a lambda f go to f, where f applied to fix of f. And now we are ready to apply the applications app1 rule, because this is a lambda abstractions. We carry out by applying the beta reductions, simply substituting the formal argument f by its actual argument, the lambda g, with the lambda x and case x of the pattern matching stuff. Okay, and if we expand this, we simply substitute this f and this f by this lambda abstraction with g, and we have the following expressions. So this is our original f being substituted by its actual argument, and this is a fix applied to f, but now f again being substituted by the lambda g. So if you look at this expression again, we can reduce it by applying the beta reduction, because the left hand side itself is already a lambda abstractions. So again, we apply the beta reductions to substitute the formal argument g with the actual argument, which is a fix applied to g of this lambda abstractions, and the only g that we need to replace is this one. Okay, so this would give us the following lambda abstraction, which is lambda x right arrow case X of pattern matching. In case it's empty list, we return 0. In case it's non-empty list, we apply 1 plus the fix of this. So this is our G, original G, being expanded now become fix of apply to this. So you can think about this is analogical to our mu G approach. Okay, so the fix of the apply this is similar to the mu G. Okay, and let this final expression to become our E1 prime, and is already in lambda abstractions. We can, going back to our earlier context or outer context, we can carry out the remaining evaluations.